This time we're going to look at question 7. Now, question 7 is extremely difficult because there's a lot going on and it's easy to misinterpret. So if you got it wrong, don't worry too much about it. This really is the hardest type of question you would ever face. So first of all, let's try and draw it. So the first thing we're going to do is say, okay, there's a dude, I think his name is Jason, right? He's in the corner of a very large field. So again, I am going to draw my little north line. He walks on a bearing of 30 degrees. So that's not much at all, right? It's less than half of my 90-degree angle. So I'm going to go up pretty steeply. So this is 30 degrees. Again, I could draw my next north line. And if that is 30, that makes this 150. All right. And the distance is D. We don't know exactly how far that is, but we do know it's D. So let's put that there. Then he goes and walks again. But this time he's walking twice as far on a new bearing of 120. Okay, so straight across is 90 and down is 180. 120 is going to be somewhere in the middle. And I have to go twice as far as before. So this is 120 degrees. This is 2D. So if that's 120, this is 60. All right, let's put in some more information. So this is 2D. And then obviously I'm going to complete my triangle. So because I have to go back again, there is a lot that's about to go on here. So let's have a go at figuring out what information we can, first of all, is there anything we might be able to add to this? Well, again, we know these two angles. Together we get 270. So this must be a right angle. So that makes our life a bit easier. Now, the wording of the question is a little bit unhelpful at this point, but let me just clarify what they're talking about. This distance is not 120 meters. The question tells us the entire distance he walks is 120 meters. That means this plus this plus this is 120. I'm going to call this X because we don't know what it is. So D plus 2D plus X is 120. Which means that 3D plus X is 120. And I'm going to rearrange this to say that X is 120 minus 3D. And this is going to be helpful information because you can't solve for two unknowns at once. But if I do some substitution, because I know that X, I can say it in terms of D, and I know that this distance is 120. So what I can actually do is rewrite that. I'm just going to change colors again. So what I can say is that actually, I might just leave that for there right now. I'm going to do Pythagoras. So I know that this squared plus this squared equals that squared, but I'm going to call X this, okay? So 120 minus 3D squared equals D squared plus 2D squared. Okay, so if I expand all of this, I can solve for D. This is going to be complicated and it's going to be a quadratic, but it will work. So if I remember, you don't just square first and last terms, write it out twice and FOIL it. So this is 144, yep. And then minus 720D plus 9D squared. Again, you can just open it up and FOIL it. I'm just doing it the fast way. This is D squared, and this is 4D squared, right? We're squaring the 2 and the D. So D squared plus 4D squared. So this is 5D squared altogether. Let's write that properly. Then I'm going to bring the D's across to this side. So I have, well, I'm going to rewrite it like this. Minus 720D plus, and then minus 5D squared equals 0. Then this is 4D squared minus 720D plus 144 equals 0. You can now use the quadratic formula to solve for D. One of these answers will make sense and one of them won't. One of them will be a ridiculous number that doesn't fit into the idea that he only walks 120 meters. So if you use the quadratic formula, you will find that D is 22.42 meters. Sorry, 22.92 meters. I've written that wrong. 92 meters. Again, just use the quadratic formula and you'll get that. So if this is D, this is 2D, right? So you just double it. So then 2D is going to be 45.84 meters. And altogether, he walked 120 meters. So 120 meters minus D minus 2D is going to be X. And if you just type the values we got into a calculator, that means that X is going to be 51.24 meters. Now that is extremely complicated, and I know that there's a lot going on there. So if that is really going over your head, either have another go, watch it again. But yeah, I wouldn't worry too much about this if you're freaking out about this, because this is an incredibly difficult question. The other thing that they're asking us to do, I'm just going to zoom out a little bit, is to find the bearing of his return trip. So the bearing of his return trip is this. So we know this bit, we need to find this bit so we can subtract it from 360 again. Now I know D and 2D, so I'm just going to use tan again. So this is my opposite side, this is my adjacent side. So I'm going to say tan of the angle is my opposite, which is D, so 22.92 over 2D, which is 45.84. And then to find an unknown angle, we always take the inverse of, I'm not writing it again, and then you'll find that your angle is 26.57. So then to find the bearing, we just do 360 minus this 60 in here, and then minus the angle we just found here, and that'll give us what's left over. So our angle, so our bearing is 273.43. Again, the book is rounding to the nearest degree, so it's just why do I keep doing that? 273 degrees if you're being asked to round to the nearest degree, which I'm not sure it necessarily says that, but that's what the back of the book does. So I don't mind either one of those answers. All right, that was an extremely difficult question. If you got it right, well done. If not, feel free to watch it again or come and ask me for some help.